Hello everybody. In today's video I'm gonna summarize a couple of things we discussed during our today's lesson, and the main task will be to sketch the graph and express the properties of linear function so that point A with the coordinates 3 and -2 and point B belong to the function. In this video you will see how we will find the equation of such a function. Then you will find in this video how to sketch the graph of the function. When we will find the equation, we will be using transformation of the parent function, which we already know is defined by the equation y equals x. And the last thing we will go through is the properties, or rather the last thing is the property. We list the properties of the function when the function will be drawn in the chart or xy plane. So before we start, let me just write down that my point A has coordinates 3 and -2, and the second point, which belongs to the function, has coordinates 6 and 7. As we already know, these points should be on a linear function, and as we already know the general form or equation how the linear function is defined. In our case it was defined like y equals a times x plus b, where a and b are any real numbers, so coefficients, yes. So as I explained, this equation requires, or what is the main goal here, is to find the values of a and b so that the equation we will get will really meet the criteria, so that the line, which is a graph of any linear function, passes through or goes through our points a and b. So as we know, point A must belong to the function, and from this we can define like our first equation, because the first coordinate of our point A is x in our equation, and the second coordinate, which is -2, is y in this equation. That's why we can really simply write this equation like -2, because this is our y coordinate of the point A, is equal to a times, and instead of x we write 3, which is the first coordinate of point A, plus b. And as we know that point B must also be part of the function, belongs to the function, from this information we can write the second equation, which will be 7, because this is our y coordinate of point B. Okay, so instead of y in this equation we again put number 7, so 7 equals a times 6 plus b. And as we discussed, this is the system of linear equations which we are used to solve, but during our lesson we were using elimination method, and especially subtraction elimination method, which means we did subtract one of these equations from each other, and that was really like a clever idea, because we simply got rid of these two coefficients, and the equation, or the system of the equation, was solved really quickly. So yeah, while I'm doing this video, I really want to show it again so that you really know how we did. So we will do like the first equation minus the second equation, which would lead to simple equation -2 minus 7, because we did subtract the left sides of both equation, equals from the first in the first equation we have 3a, take away 6a, so we took the first term from the right side of the first equation and the first term of the right side from the second equation. That's why we have 3a take away 3/6. And good news, this is what we found out during our lesson, that b minus b will cancel each other, so there won't be any b anymore. So we will get the equation -9 equals -3a, simple equivalent procedure. So we will now multiply both equations by -1/3, so our result is a equals 3. As far as we have a parameter or coefficient, we can simply calculate the b, because we really found that a is 3. So now we have this information, and we are now supposed to find what b would be, which numbers is there. So then now it doesn't matter, we can choose even the first or the second equation, and we put the information about a into one of these equations, and we will calculate b. So let me choose equation number 1. So it's gonna be -2 equals a is 3. We already know 3 times 3 plus b, and from this equation we can see very easily that b is equal -11. Okay, so you can use this procedure, which is called solving a system of linear equations by substitution, and like subpart we used the subtraction, not substitution, subtraction, elimination. Okay, so we eliminated one of the terms in the equation. So conclusion from this would be then that our function, so that point a belongs to the function and point b belongs to the function, would be the function which is defined by the equation y equals, we found out a is 3, so it's gonna be 3x, and now as b is negative number, it would be plus minus 11, but we don't use this kind of notation anymore, because we know that plus and minus will lead to the -11. So this is our equation for the function. Okay, I'm not gonna show the substitution method because of time. If you want to, you can find out on the internet how to solve, or maybe I'll do it later. So as far as we have our function, we are now ready to draw the graph of the function by using the transformation, which basically means we will transform the parent function. Let me denote it by green. So our parent function is y equals x. Let me draw the xy plane, and as you probably know, the reason for drawing xy plane like this is very simple, because this number means that we will move the parent function, or not parent function but 3x function, after the first transformation 11 points down. But let me slow down. So here is, for example, point 1 and point 1, which basically is good to sketch, because our parent function will now pass through the origin and through the point which coordinates are 1 and 1. So let me draw the graph like this. So this green line is really our parent function. Now we know that the next thing to do, or next step, is that we simply multiply our parent function by number 3. So we will now try to draw the graph of function which is defined by the equation y equals 3 times x. which basically means, and I was explaining what the number 3 is representing here, and as you probably remember, this is called slope, and it defines if the function is steeper or not steeper than the parent function. As it is number 3, and as this number is greater than 1, the graph will be steeper. And let me remind you what the slope and what number 3 here means. It means that if you move, and let me just use the purple color, if you move 1 unit to the right, then this number tells you how many units you should go up. So in this case, we moved 1 unit to the right, and we need to move 3 units to the up. So I'm missing in my graph next points 1, 2, and 3. So now I know that my blue line will pass through the point with the coordinates 1, 3, which can be very easily calculated when you fill in this equation with x being 1. Then you will of course get number 3 for y, and we have now again 2 points which are enough for drawing any straight line. So, because the second point is in the origin again, so let me sketch now our graph, or a line which represents function y equals 3x. So this is our function y equals 3 times x. And the last thing we will do, and let me use the red color, we will sketch the graph of the function which is really like our function, and the final one, 3 times x take away 11, which basically means, that all the points of our blue line are moved 11 points down. That's why I was really drawing this part of the graph so long here, because I need 11 points down. So it's 1, 2, -1, -2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is my point, because the origin was also moved 11 units down. So my point from 0 to 0 was moved to the point with the coordinates 0, -11. And as far as we already know, and this is quite new, maybe new information, as we didn't change the slope of this function and this function, this gives us the information that my red and blue lines should be parallel. I'm not sure if I will do it like really parallel, but I'll try, I'll do my best. So yeah, I think approximately it is okay. So these two lines are parallel because their slopes are the same. Okay. Basically, if you would check the slope again, okay, I'm not gonna explain that because it's kind of information which is not needed now. So our red line is representing our function, which is defined by the equation y equals 3x take away 11. We are done here. So this is our graph. Let me just say one thing. Let's consider the green function being like gx equals x. Okay, then we used the transformation of gx, and okay, let me put it here. Also we did the transformation h. Okay, and the function h of x could be defined like 3 times gx. So it means we multiplied each value of the gx function by 3. That's why all the points, that's why the blue line is steeper than the green one. If this would be not number 3, but let's say some number between 0 and 1, then it wouldn't be so steep as the blue. And let me define, okay, we have our function f, so our function f of x is defined as 3 times g of x plus take away 11. Okay, so here you can see why and what are our transformations. The first transformation is that we multiply each y value by number 3 and then we take away number 11. Okay, that's why all the points from my blue line are 11 points above the points from the red line. So this point is here, and my new point would be somewhere here, and this distance is 11. Okay. Now the last thing we want to do here in this exercise is to express all the properties, and when we do so, I will explain also how to find the intercepts of our function 3x take away 11. Okay, so we will start with the properties, and the first property we really need to write down about our function. And let me just take my function and my graph down here so that I really have everything what I need. So let me take this graph and let me put it here. Okay, it fits perfectly. Okay, so this is it, and we now start with the properties of our function. And the first property we are interested in is the domain of our function. As we already know, all the real functions have the domain all real numbers. Then we have the range of the function, which are all the y values, and we already know that these are also all real numbers. Next, we know already, and we can see from the graph that the function is increasing. Okay, so it's increasing, and let me just say that we could read this even without drawing the graph of the function, because we know our parameter in the equation is number 3, which is positive number. Okay, then the function is not even, it's not odd. Okay, not even, not odd, and it's unbounded, has no minimum, has no maximum. Okay, is it one-to-one function? Yes, it is one-to-one function. Why is it one-to-one function? Because there doesn't exist any horizontal line that would intercept my red line more than once. Okay, that's why the function is not one-to-one and is not periodic. And I think this is it. Yeah, graph is of course straight line. Okay, line. Okay, now I was explaining also, and I said that we will find out what is the intercept of the x-axis of our function and what is the intercept of y-axis of our function. As I already said during our lessons, this is really easy to find, because we know that the intercept with the x-axis, and this is basically this point. Okay, and we already know that all the points that belongs to the x-axis have the second coordinate 0. So we have to find like only the first coordinate. Let me do it another way as I did it during the lesson. So let's find what is the x. We already know that y equals 0, so we will use our equation and we fill in all the information we have. So it would lead to the equation 0 equals 3 times x take away 11, which means 3x equals 11, so x must be 11 over 3. So our coordinate of the intercept with the x-axis would be 11 over 3, which is basically this point which I was not able to define. So now we know that this point's coordinates are 11/3 and 0. Okay, it should be 11. Okay. The same procedure applies for the intercept with the y-axis. So this is any point that is on the y-axis, and as we already know, all the points on the y-axis have the first coordinate 0, so we simply just calculate the y value for our intercept. Let me use this color. So to calculate this, you simply again fill this equation with the information you have, and it would lead to the equation 3 times 0 take away 11, so y equals -11. And this is really true, because as we already saw, this is like -11, and as it was said during our lesson, parameter b always tells me what is the second coordinate of y-intercept. So as we found out, this is -11. Okay. The last thing I want to do here is to really show you that it's clever idea when you do your homework, or when you find out any functions, or try to find the definition of the function, and you want to check your solution. The easiest way is to use the Desmos program, where you just fill in your equation, and the result will be there for you without drawing anything, and you can check your work. So basically I have the picture ready. So this is the result from the Desmos, and as you can see from this picture, our graph is really almost, though I would say it's really the same graph, and you can check with Desmos, and as you can see here, this is really -11. And if you would use Desmos and put the mouse over this point, you will see that the coordinates of this point are really 11/3 and 0. You see that the slope of the line is almost the same as we expected. Okay, let me say one more thing. What is the slope? We said that the slope means if we move 1 unit to the right, then we have to move 3 units up. So let's check if this function really has the slope 3, or this graph, or this line, or linear function if you want to. The easiest point where to check with this graph would be to take this point, for example, and as you can see, its coordinates are -5 and 2, so you move it 1 unit to the right, and then you just count the units to go up. So 1, 2, 3. So it really fits, or it's true, and it fits with the information that the slope of our graph should be 3, and as you can see, it really is 3. And this must apply on any point you take from the graph. So let me just check or show you with this one. You move 1 point to the right, and then you move 3 points up. So again, it fits. Okay. I think that's all for now, and this is basically it. Thanks for watching, and enjoy the video. See you on Monday. Bye bye.